Welcome to Chapter 6, Homework Questions 41 through 46. Fabian compared annual grocery bills with other mothers at her church. She discovered a linear relationship between the total cost in dollars of groceries and the number of miles the mother lived from the downtown church. Part A, do you think that the association would be positive or negative and strong or weak? Really depends on how you look at this problem. You could talk about potentially it being negative depending on if the in-town prices can be higher than the prices that are out of town. Out-of-town families may grow some of their own food. You could potentially say it's positive because maybe the transportation costs make out-of-town prices that are higher. There's just a lot of different things that you can say here. So positive or negative, you just have to give your explanation. Strong or weak, I would probably say it's weak on this one. Just because there's not necessarily, she discovered that there's a linear relationship, but it doesn't seem like there's a big correlation between those two. So even though there's a linear relationship, it probably is weak. For part B, the upper boundary for Fabian's prediction was modeled by G equals 11.27 minus 0.14 D, where G is the cost of the groceries in thousands of dollars, and D is the distance from the church in miles. The lower boundary was G equals 7.67 minus 0.14 D. Estimate the equation of Fabian's line of best fit. Now, if you take a look, your slopes for both of these scenarios are going to be the same. Remember, your upper and lower bound is going to be dealing with that distance, and they're going to be parallel to each other. So that's why those slopes are the same in each of those. We need to estimate the equation of Fabian's line of best fit. And so since the upper and lower bound has the same distance away from the line of best fit, and the slopes would be the same, then we really need to find the middle of these two. What's halfway in between 11.27 and 7.67? So we can, how would we figure out the middle between those two? So I'll go down here and we can take 11.27 and subtract 7.67. That will give us the distance between the upper and the lower bound, which is 3.6. And that's the distance between them, but we want the middle of that. So to get the middle of that, if we divide by 2, we'll get 1.8. And so that's the distance between the line of best fit and the upper and the lower bound. So we need to then take, whether you take 11.27 and subtract the 1.8, or you can take the 7.67 and add the 1.8, we should get a value of 9.47. So therefore our equation would be G is equal to, now your y-intercept would be 9.47. That was in between the two upper and lower bounds. And then your slope is still going to stay the same, though, 0.14 D, which represents the distance from the church. So that would be your estimate of the line of best fit. Part C wants us to interpret the slope of Fabian's model in context. So the slope in this model is negative 0.14. And so once again, remember it's the change of y over the change of x. Now the change of y in this case, our y represents the dollars, which they said as G. So the change of G over the change of x, which is the distance in miles, and they had that as D. So the 0.14 represents the dealing with the cost, and the D represents the distance. So what does that slope represent? For each additional mile from church, we expect families to spend $140 less for groceries that year. And remember, the reason that's 140 with the 0.14 is because this is measured in thousands of dollars. So 0.14 would be $140. All right, and on to the last part. So this actually answers that question. And then D, Fabian lives 8 miles from church. Her residual was $510. About how much did she spend on groceries this year? So first, let's go ahead and find the predicted. So the total cost for the groceries, 9.47 minus 0.14 times the distance of 8 miles. So the predicted cost of groceries would be 8.35. Now remember, once again, it's measured in thousands of dollars. So that is equivalent to $8,350. I shouldn't say equal to, but that's what it represents, excuse me, in terms of thousands of dollars. So that's the predicted. So this is the predicted. The residual is 510. So remember, when we find the residual, we take the actual minus the predicted, and that's supposed to be the residual. So if I plug in what I know, the actual we don't know, so we have the actual minus the predicted, which is 8,350 is equal to the residual of 510. So if we want to solve this, we can add 8,350 to both sides, and that will give us an actual grocery bill of $8,860. So about how much did she spend on groceries this year? Based on the information, it looks like it'll be about $8,860. Question 42. Robbie's class collected the following view tube data in problem 6-1. The x value is the distance from the wall in inches, and the y value is the width of the field of view in inches. Use your calculator to make a scatter plot and graph the least squares regression line. Sketch the graph and the LSRL of each on your paper. Remember to put a scale on the x-axis and the y-axis of your sketch. Write the equation of the least squared regression line rounded to 4 decimal places. So, since I can't really show you how to do this on the graphing calculator on the video, I went ahead and gave you the scatter plot and the LSRL so you could see what that is. You have your scales on the x and the y-axis. And then the equation that comes from this, and once again, this would be something that you got from your calculator, would be y is equal to, and it does want us to round to 4 decimal places, so it would be y is equal to 0.1336x plus 1.6568. So once again, all of this question you need a graphing calculator for. So all of that information is found on the graphing calculator. On part B, it says, with your calculator, find the residuals as you did in part C, all right, of problem 6-33. Make a table with the distance from the wall in inches, so that's your x value, as the first column, and then the residuals in the second column. What is the sum of the squares of the residuals? So similar to what we did in class. So we're going to create a column of distance from the wall. We need the predictions so that we can find the residuals, and then the residuals squared. All right, I went ahead and completed the entire table because it was just too much work waiting for me to write all this stuff down and listening to it. So I'll just kind of go through what I did here. The first column is the distance. That's the independent variable, or x. That's the distance from the wall. The next one is the prediction, which is your y value. These are the actual values up here, okay? And then these are the predicted values of the width of the field of view. And then to get the residual, you take the actual data. So I took my actual data from above and subtracted the predictions, and that gives you the residual. And then the last column is the residual squared, which is what the question is asking. What is the sum of the squares of the residuals? So that's why I created that fourth column. All of this information came from the graphing calculator. The only one that wasn't from the graphing calculator was column Y. Well, I shouldn't say necessarily column Y, but this predicted value. This I calculated by plugging it back into the equation and figuring out what that prediction was. But the residuals and the residual squared came from the calculator. And then the question is, what is the sum? Down here on the very bottom, I used the graphing calculator to find the sum of that last column. For me, it was the list 4. And I got 0.5881 inches squared, and that was rounded when I calculated it as well. So I hope that helps. If you have additional questions on this one, definitely please ask your teacher. Question 43, solve each equation for x. So we have the first one. I'm going to go ahead and distribute the -2. So 10 minus 4x minus 2. And I'm going to go ahead and distribute the 4 as well. So that'll be 4x minus 8. We can combine our like terms. 10 minus 2 is 8. So 8 minus 4x is equal to 4x minus 8. If I subtract 4x to both sides, I will get 8 minus 8x is equal to -8. And then subtract 8. Get -8x is equal to -16. Divide by -8, and x is equal to 2. And we can always check our answers by plugging it back in. For part B, now this one there's a -1. You don't see the 1, but you still have to distribute the negative. So it's 5 minus 2x, and then a -1 times a -3 is a +3. And then we'll combine our like terms on the left side. 5 plus 3 is 8. 8 minus 2x is equal to -8 plus 2x. Subtract 2x to both sides. And remember, there's multiple ways to solve this, so if you didn't do it exactly this way, it doesn't mean you did anything wrong. Just getting the variable on one side and the constant on the other. And then if I divide by -4, I get x equals 4. And once again, we can always check by plugging it back in. The cost of a 55-inch HD TV is decreasing 15% per year. What is the multiplier? If the current cost of the HD TV is $1,500, what will it cost in 4 years? And then if the current cost is $1,500, write an equation for the cost in N years. Once again, even though that last question is write the equation, you could write it earlier to help you answer question B. So first off, the cost of a 55-inch HD TV is decreasing 15% per year. So what are the things that we want to identify? We want to identify our variables. So let's let T equal the time, and the time is measured on this problem in years. And then the other thing that we are looking at is the cost. So we'll let C represent the cost of the HD TV, and that's measured in dollars. So what is the multiplier on this one? Well, it's decreasing at 15% per year. So remember, we start off at 100%, and if we're decreasing 15%, it's going down. So therefore, that's 85% of the original cost. So your multiplier is 85% as a decimal, which is 85 out of 100, or 0.85 in decimal form. B wants us to answer the question. On the last homework assignment similar to this, I did B and then I did C. I'm actually going to go ahead and write the equation first, and then I'll go back and answer B. So if the current cost of the HDTV is $1,500, so remember that represents your initial cost. And then we want to write an equation for the cost in N years. Now I just realized that it does say, well, I guess it doesn't matter, that's okay. It says in years, so typically we would use N for our time then, because it does say that. So I'm going to go back here under my let statement and just change it to an N to match up with that part C. So let's see. So we're going to write an equation. So we have C, which is the cost, is equal to the initial value of $1,500 times your multiplier, because it is decreasing, so that number has to be less than 1, and then raised, because I changed it from T to N, raised to the N power. Okay, so other ways that you could write this, you could write it as a sequence where you could say T of N is equal to 1,500 times 0.85 raised to the N. We also use the notation A sub N is equal to 1500 times 0.85 raised to the n. So there's a couple of different ways that you could write it given what you wrote your let statements as and things like that. So those are some possibilities. But now I'm going to go back to part B and actually answer it, because now it wants to know what will the cost be in 4 years. Now that I have my equation, I can just plug 4 in for n and say the cost is equal to the 1500 times my multiplier raised to the 4th power. And then when we plug this into the calculator, we will get approximately a cost for the HDTV for $783. And if we round to the nearest cent, it will be 0.01. So the cost for the HDTV in 4 years will be $783.01. Question 45. For each graph below, what are the domain and range? Remember, domain represents your x values and the range represents your y values. So for part A, domain, since they do not have arrows on them, it starts at -2 and goes all the way up to +2. That's the x-axis that I'm looking at in terms of the values, how far that line begins and ends. So we're going to say that x is greater than or equal to, because it is a closed circle, at -2. Let me give myself a little bit more room here. So x is greater than or equal to -2 and less than or equal to 2. Take a look at the range, your y value. So same thing, it does have a beginning and end. The lowest is -3. The highest on the y-axis is 2. So we're going to say that the y value is greater than or equal to -3, but less than or equal to 2. Part B, your domain. So this line is vertical. The only number it hits is 2. So your domain is x equals 2. And then your range, and that's the only value of your domain, and your range is going to cover all real numbers, because it's going to continue to go down, it's going to continue to go up, it's going to hit every single number. So your range is all real numbers. On part C, your domain, once again we're looking at the x, the farthest left it goes is -2, and these arrows indicate that it continues to go on forever, so it's going to be all values of x that are greater than or equal to -2. Your range, so as this goes down, you don't know where it ends because it just continues to go down, so it's going to go down forever, and then on the other side, as it works its way up, it's going to go up forever because of the arrow there. So your range for this one is also all real numbers. It will cover the entire y-axis, or the y values, as it goes up and down. And then D says which, if any, of the graphs represents functions. So remember, a function has to pass the vertical line test when you're looking at a graph. Every x has to have exactly one y. So which one of these represents a function? A represents a function. There is no x that goes to two different y's. B is not a function. You have lots of x values. That's what the domain is x equals 2. So, for example, this is the 0.22, and then this is the 0.2 comma -3. So you can see how that x value is going to two different y's. And then on C, that is not a function as well, for the same reason. If you look at, let's say, x equals 2, you have this point here, and then you also have this point down here where the x value is 2. So therefore you have one x going to different y's, so therefore it's not a function. So it looks like on this one, the only one of these graphs that represents a function is graph A. Question 46. For each sequence defined recursively, write the first few terms, then use the terms to write an explicit equation. So going back to sequences, this is written in the alternative form a sub 1 and a sub n. So a sub 1, this represents the first term. All right, and then a sub n plus 1 is the next term. So you take the previous term and subtract 3. So that means a sub 2 would be 14. A sub 3 would be 11. It just says write the next couple terms. And so if you subtract 3 again, you would get 8. So write the first few terms, which I did. And now we want to write an explicit equation. So, sorry about that. We would have a sub n, so that's any term of n, so any term that you want to find is equal to. Now this is a arithmetic sequence because you are adding a negative 3. So that means that you would take negative 3, multiply it by n, and then you're going to add that initial. Now remember, we have a sub 1 is 17, so we want the a sub 0. And since we're subtracting 3, we'll add 3 to get a sub 0, which is 20. And that would be our initial, or term 0. So a sub n is equal to negative 3n plus 20. Negative 3 is what you are adding each time. So there's your explicit equation. For b, we have a sub 1 is 20, and then to get the next term, you're going to take half of that. So if 20 is the first term, if you take half of that, that's 10. Half of 10 is 5. Half of 5 is 2.5. So to write the equation, this one is a geometric sequence because you're multiplying. So a sub n is equal to your initial, which once again, even though this is the first term, you want term 0. So we have to work backwards, which means this would be 40. So it's your initial times the multiplier, which is 1/2, raised to the nth power. So the first one is arithmetic. The second one is geometric. Remember, arithmetic is repeated addition, and geometric is repeated multiplication.